Ladies and gentlemen, please welcome Mrs. Renee James. 让我们欢迎詹瑞妮女士。
Good afternoon. In life, they say that the journey, it's about the journey and not about the destination. And the same can be said about technology. It's ever evolving, ever moving, and never done. For the past 30 years, Intel and the Taiwan technology industry have been on a journey together. We've achieved many milestones, but they're just that. They're just road milestones or mileposts along a path to future technology. Throughout the history of our industry, we've read countless claims that it's over. The growth has stopped, this product is dead, that product is finished, and whenever the headlines predict that we've come as far as is possible, that we've reached the end point, our industry proves time and time again that isn't so. Because innovation and invention waits for nobody and stops for nothing. I want to welcome all of you to Computex 2014. This is a show that's about innovation, it's about our industry, it's about technology, and it's about an ecosystem that was built in Taiwan that will never stop, never slow down, and is on the journey to the next decade of computing. As we approach our 30th anniversary in Taiwan, even longer than I've been at Intel, I want to take a moment and remind ourselves of how much we've accomplished together. We, as an industry, have done many things that people said couldn't be done. Our mission is, at Intel, and always has been, to invent and make possible a future that nobody asked for, nobody has thought about, but will enable everyone and change the way that they work, play, and live. So I'd like to take us back a little bit. For some of you, this might be new. For others, you'll remember all of this. I want to start at the beginning. And the year was 1989, the year that the Taiwan industry, represented here today, shipped the first Intel-based PC motherboard. And it looked like this. It had 32 megabytes of RAM. The processor ran at 33 megahertz. And not that there will be a quiz, but later today we're going to see things running at gigahertz. So I just want to kind of calibrate you. There were 25 separate chips on this motherboard, and it had a whopping 256K cache. That was the state of the art. And now it's a museum piece. Today, you can see the new motherboard on the screen. I'll go forward here. There we go. This is a small form factor for the desktop system motherboard. 4th generation Core i7 at 3 gigahertz with a 4 megabyte cache and HD graphics. And just to kind of give you an idea of how much we've accomplished in that time frame, I want to show you the size of each of these. You can see that. The processing speed is 100 times greater in this than this. There's 500 times more memory in this board than was in this, and the size has shrunk by 75%. That took a tremendous amount of innovation. And that innovation is what you, in this industry in Taiwan, have delivered. And Intel wants to thank you. Thank you for that. In 1987, there were 53 companies in the worldwide, what then was the computing industry was largely the PC client industry. And we were shipping 5 million units. At that point in time, there were famous CEOs who were saying, you know, we don't know if anyone ever really needs a computer on their desk. And we were all wondering, how big can this really get? A decade later, we had shipped 100 million units. Driving to that 100 million unit was growth and innovation of the Taiwan industry. In 1998, the ecosystem had grown to 88 companies, including companies such as Acer, who were stepping forward with brands, worldwide brands. Taiwan and Intel had worked together to innovate on standard form factors and lowering the cost so that we could build more affordable computing. And again, there were those who said, we've reached our destination. 100 million units of anything is a lot. Really? Can there really be more? And in 1999, the then CEO of IBM claimed the PC era is over. And in the next decade, we shipped another 130 million units, which was yet again another tremendous accomplishment. And we weren't done. And what we didn't know when we reached this milestone, that we were at the beginning of one of the biggest growth phases of our industry in the internet boom. While Taiwan had shipped 500 million motherboards in the previous 10 years, going forward, we would ship yet another hundreds of millions of units. In 2003, we worked together to change the industry again. And we invented Centrino together. Built-in Wi-Fi. Who would use that? What would we do with it? And because you bet with Intel, you, the industry in Taiwan, took a bet with us. And we built Wi-Fi in, and we built laptops nobody had ever considered. And we were able to go to hotels, airports, restaurants, and put in Wi-Fi and change the way people used computing. And from that, the mobile computing internet era was born. In 2005, it was over again. And then, of course, by 2011, we were well over 300 million units. So, as I said in my opening comment, this is a journey. It is not a destination. Our industry continues to reinvent itself. That's what's so exciting about what we do here. That's why we come to Computex. That's why every year we get excited about what's new, because we know we're not at a resting place. And inevitably, when people start claiming that it's the end, that's exactly the point when our industry creates some new invention, some new innovation that brings new users and some new experience to computing. And the journey continues forward, as it has in the past several years. The past several years, the journey has continued forward again, ushered in by touch, ultra mobility, low power, high performance and low power, and as a result, another 233 million units have been shipped in tablets. So despite conventional wisdom, a tablet is a multi-purpose computing device. And it's the kind of device that was pioneered between Intel and the Taiwan ecosystem. So when you add this together on our journey, what we see is that our business that we've been building together for the past 30+ years is a 500 million unit of multi-purpose compute. And in fact, we're not done. We have a whole new category of compute that's upon us in wearables, Internet of Things. And if you look at the projections, Internet of Things is supposed to be 50 billion units by 2020 on its own. We believe that computing is a continuum of experiences. It's no one form factor, it's no one device, that from the smallest of wearables to phones, to tablets, 2-in-1 PCs, high-performance desktops, and of course, servers that power the cloud. That spectrum is what delivers growth into our industry. As computing becomes more pervasive across all of these different form factors and experiences, there is another important vector that's emerged, and that's the vector of integration. The next era of computing is going to be about integration. It's going to be about computing being integrated into our environment, into our cars, our watches, our desks, our homes, our clothing. But most of all, computing is going to be integrated into our lives. And not just through the devices that are, but everything that's around us. This is the journey we are just beginning. And like in 2005, when we couldn't see before us, that there was still all of this growth coming. We look forward and we don't know. We have lots of discussions about, is this it? Is this all? Are we sure? Are we done? This is the journey that we're beginning on. And like the past 3 decades of computing, it is fueled by the underlying technology building block of this industry. And that building block is semiconductor technology. Our compass for what's possible in semiconductor technology has been and still is Moore's Law. And when we look at Moore's Law, and I think most of you know what Moore's Law is, but for those of you that don't, it's the prediction that the number of transistors will double roughly every 2 years. And that prediction has been driving Intel forward to this point, and it continues to drive us forward. And as we see on the slide behind me, Moore's Law delivers more than just performance. It allows us to achieve improvements in power and in cost. As we transition towards integrated computing, lower power requirements become more important, integration becomes more important, and performance continues to be important. So it wasn't that long ago in our industry that we couldn't imagine building a 22 nanometer transistor. Today, we have 14 nanometer, and we're going to talk about that product later this afternoon. And we can see our way clear to 10 nanometers. So some of the claims in the industry are that these new kinds of devices behind me on, I guess, your left side, they don't need that kind of scaling. We simply do not agree. All of the vectors of improvement are essential to deliver the desired user experiences in all types of devices. Core semiconductor technology is how we raise the performance and reduce the power consumption. How we shrink into new form factors at the same time as we pack in all the new features that we're going to demonstrate today. That's how we got from those older motherboards to the smaller ones that I showed you. This evolution in this continued progress forward is the foundation technology that fuels our industry and will fuel the next era of computing. Integrated computing requires capabilities in these 3 areas, and we're going to demonstrate all of this. It all has to happen smaller, thinner, and lighter. Performance I/O and communications are critical, and so what I'd like to do is take a look at the progress and where we're at in each one of these areas and how we're moving forward in creating the foundation for integrated, smart, connected devices. Intel has developed a broad range of SoC options to enable thin and light in phones, tablets, 2-in-1s, from entry-level Atom to full performance core processors. All with great battery life, all what consumers expect from a mobile device. They're scalable solutions, compatible, scalable, and it allows our customers and you, the computing industry, to develop a wide spectrum of products and multiple different price points and quickly turn developments. We've been talking this year a lot about our progress in tablets, and we've been very public that we're on a path to deliver 40 million units. So I want to update you on how we're doing. There are over 130 new designs that are in the market or coming soon on the Atom, Bay Trail, Merrifield, and Moorfield designs. At this show alone, 12 new tablets will be launched, Intel tablets, and we're well on track to our goal. All of our tablets are shipping 64-bit ready, and will support with a simple Android upgrade 64-bit. And one of my favorites, actually, is the Icona 1.7 from Acer. I hope it's behind me right now. It's sleek, it's slim, and it's just 8.9 millimeters thin. So I'd like to actually just pause for one moment and congratulate the Acer management team. They have had tremendous innovation and a whole new series of Intel products that they recently launched in New York, and I really want to congratulate them on all of those efforts. So our industry is pretty, we haven't been as sophisticated as we might need to be about tablets. We've been talking about the tablet as if it's a single product, which we all know it's not. It's really much more than that. We have multiple different design points, different screen sizes, different performance, different graphics, different connectivity choices, and different usage models. And they can run Android, they can run Windows. So our partners can now field a broad line of Intel tablets. Different price points, different users. Maybe you want Windows, maybe you want Android. The flexibility in our product lineup now enables our partners to do a lot of creative things. So what I would like to do right now is invite one of our partners who's doing just that to come and talk to you about what they've been doing. I'd like to welcome the General Manager